Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. In this module, we are going to see about the historical, technical and legal context, which include introduction, basic principles of radio, digital system, airborne radio system, navigation, interference and maintenance. Radio navigation. Radio navigation or radio navigation is an application of radio frequencies to determine a position of an object on the earth, either the vessel or an obstruction. Like radio location, it is a type of radio determination. Basics of radio. If a wire is fed with an alternating current, some of the power will be radiated in space. A similar wire parallel to remote from the first will intercept some of the radiated power, and as a consequence an alternating current will be induced, so that using an appropriate detector the characteristic of the original current may be measured. This is the basis of all radio system. The above involves a transfer of energy from one point to another by means of an EM wave. The wave consists of two oscillating fields mutually perpendicular to each other and to the direction of propagation. The electric field E will be parallel to the wire from which the wave was transmitted, while the magnetic field H will be at right angle to the snapshot of such a wave, where the distance shown between successive peaks is known as wavelength. The velocity and wavelength of an EM wave are directly related to the frequency of alternating current generating the wave. A radiating wire is most efficient when the length of it is equal to the half of wavelength. The EM spectrum and propagation. As can be seen from the previous paragraph, the frequency of radio wave is an important consideration when considering antenna design. In addition to the behavior of the wave as it propagates through the Earth's atmosphere is also very much dependent on the frequency. However, before considering propagation, we will place radio wave in the spectrum of all EM waves. In doing so, we will see that the range of frequencies we are concerned is with a small when compared with the complete spectrum. By general agreement, radio frequencies are categorized. There is less agreement about the letter designation used for the higher radio frequencies, which are tabulated with approximate frequency range. Finally, the list frequencies used for airborne radio system are by international agreement. Here is a table of radio frequencies which shows the class, abbreviation and range of the frequencies. Have a glance at it. Modulation. Being able to receive a remotely transmitted EM wave and measure its characteristic is not itself of much use. To form a useful link, information must be superimposed on the EM wave carrier. There are several ways in which the wave can carry information. All of them involve varying some of the characteristic of the carrier, amplitude or frequency modulation, or interrupting the carrier pulse modulation. The simplest and easiest way in which a radio wave is made to carry information is by using Morse code, switching the transmitter for a short time interval corresponding to a dot or for a longer interval corresponding to a dash, and enables a message to be transmitted. In a radar, the information which must be superimposed is simply the time of transmission. This can easily be achieved by switching on the transmitter for a very short time to produce a pulse of EM energy. Both amplitude modulated AM and frequency modulated FM carriers are commonly used in the airborne system. With an AM, amplitude of the carrier represents the amplitude of modulating signal, while the rate of change of amplitude represents the frequency. With FM and amplitude of frequency, modulating signal is represented by the frequency deviation and rate of change of frequency of the carrier respectively. Multiplexing. In most airborne systems, the required number of channels is obtained by allocating non-overlapping bands of frequencies centered on specified discrete carrier. This is known as frequency multiplexing. Shannon's sampling theory shows that a sine wave of frequency FM can be completely specified by a series of samples spaced at no more than half FM seconds. To transmit speech where the highest frequency component is 3000 Hz, we need to transmit a sample of instantaneous amplitude every 1 of 6000, that is equal to 0.0001667 seconds. Thus, we have the time intervals during which we can transmit samples of other signals. The number of signals we can time multiplex on one carrier depends on the duration and frequency of each sample. The shorter the sample duration, the greater and the bandwidth is required, confirming the statement made earlier that more information requires wider bandwidths. Basic receivers and transmitter. A much simplified transmitter block diagram is given below. This could be the all-purpose block diagram since it could easily be converted to a low-level AM transmitter, little if any application of carrier before modulation, a high-level AM transmitter, little if any application of carrier after modulation, an SSB transmitter introduce a band-pass filter after the modulator, or an FM transmitter introduce a frequency multiplier after the modulator. Obviously, in the example of the circuit detail would vary greatly, particularly in the modulator, and if detailed block diagram were drawn, the underlying similarity in the structure would be less obvious. The most biased type of receiver is a tuned radio frequency TRF. However, this is rarely used. The standard receiver configuration is the super heterodyne, that is super het. A desired RF is converted to a constant intermediate frequency by taking the difference frequency after mixing the received signal with the output from a local oscillator LO. Since the most of amplification and selectively is provided by constant frequency and bandwidth stages, the design problem is eased. In both the transmitter and receiver, RF oscillators have to be tuned to different frequency. In the transmitter, it is the MO, master oscillator, while in the receiver it is LO. Modern practice is to use a frequency synthesizer with a single crystal to provide stability and accuracy. Digital systems coding. Most of the airborne systems in use are basically analog, that is, they deal with the signals which represent various quantities continuously and smoothly. For example, in DME, small increase in range results in a corresponding increase in time. We say time is an analog of distance. With a digital system, information is represented by a number of encoded in some suitable way. Since it is difficult to detect many different voltage or current level, only two are used, and this leads to expressing number to the base 2 binary code where only digits 0 and 1. It remains to define electronic representation of 0 and 1 in an unambiguous way. Binary and hexadecimal codes are used in the digital computers. Octal code is used for the ATC transponder. The task of frequency selection is one in which tends to itself to the coding, and among several which have coding used, the two most common are binary coded decimal BCD and 2 from the 5 2 or 2 by 5. Both of these codes retain the decimal digit flavor of the number to be encoded at the expense of using extra bits. Error checking can be used with the binary codes. We will always be restricted to a certain maximum number of bits, one which can be designated a partly bit used solely for error detecting. Suppose we had 8 bits available. Each group of 8 bits would be called a word of length 8, commonly called a byte. The first 7 bit of the word would be used to encode the decimal digit 0 to 127, while the 8th would be partly bit. For odd parity, we set the parity bit to 0 of 1 so as to make a total number of ones in the word odd similarity for even parity. Thus 610 equal to 00001101 odd parity. To consider a practical application of the above, suppose a particular frequency is selected on a control unit, we may have the following sequence of events: information from controller 2 by 5 code, conversion from 2 by 5 to binary, microcomputer processes binary data, conversion from binary to BCD, BCD fed to frequency synthesizer, conversion from BCD to special code fed to readout device. Where a limited number of actual words need to be encoded, example distance, speed, heading, etc., special codes may be designated. Such codes are described in ARINC specification 429-2, Digital Information Transfer System DITS. Microcomputers. The microprocessor are bought powerful computers on an aircraft to perform a number of functions, including solution of navigation equation in a more sophisticated way than before. A microcomputer consists of microprocessor and several peripheral integrated circuit chips to help the microprocessor perform its function. There are 4 basic parts of computer: micro and otherwise memory, arithmetic logic unit ALU, control unit, and input and output unit 1.0. In a microcomputer, the ALU and control unit are usually combined on a single chip, the microprocessor or central processing unit CPU. The memory contains both instructions and data in the form of binary codes. Memory is one of the two basic types, read-only memory ROM and random access, that is RAM. The ROM does not remember any previous state which may have existed. It merely defines a functional relation between its input lines and its output lines. The RAM could be termed read and write memory. Since data can be both read from memory or read written into memory, that is, its state may change, information in RAM is usually lost when power on is switched off. The ALU contains the necessary circuitry to allow it to carry out arithmetic operations such as addition and subtraction and logical functions such as Boolean algebra operation, combination of NANDs and NORs, etc. The control unit provides timing, instruction and synchronization for all other units. The control signals cause the other units to move data, manipulate number, input the output information. All this activity depends on a set of step-by-step instructions known as program which reside in the memory, the 1 or O unit in the computer interface with the outside world. It can be seen that the units are interconnected by three main buses. A bus is a several electrical connection dedicated to a particular task. A unidirectional bus allows data to flow in one direction only, unlike the bidirectional bus where the flow is two-way. In a microcomputer, we usually have address bus 16 unidirectional line, data bus 8 or 16 bidirectional line, control bus the number of line varies with the system may have both unidirectional and bidirectional line. Categorization of airborne radio equipment. Frequency and modulation. Since the technique involved vary greatly with the RF and type of modulation used, it is often useful to categorize equipment as to the band of frequency in which it operates and being pulsed, AM or FM. From both the design and maintenance point of view, the frequency at which equipment operates is perhaps more important than the modulation used, at least in so far as choice of components and test equipment is concerned. The higher the frequency, the greater the effect of stray capacitance and inductance, signal transmit time, and skin effect in conductors. The microwave region SHF and the high end of UHF waveguide replace coaxial cables certainly above 5 GHz and special components whose dimensions play a critical part in their operation and are introduced, klystrons, magnetrons, etc. Analog digital. These terms have already been mentioned and certain aspects of digital system have been discussed. In modern airborne system, the information in the radio and intermediate frequency stage including the wireless RF link is usually in analog form, the exception being secondary surveillance radar to be joined in the future by microwave landing system, data link and replacement of SSR. In the addition, common use transducers such as synchros, potentiometer, microphone, telephone and speakers are all analog devices. Not all transducers are in the analog category. A shaft angle encoder used in encoding altimeter is basically an analog to digital converter, with the exception of almost everything else in the current equipment is digital, whereas previously systems were all analog. There is further subdivision within the digital equipment in those using a combination of hardware and software, computer controlled, and those using only hardware, hardwire logic. The trend is towards the former. Function. The two basic categories with regard to function are communication and navigation. If navigation is defined in its widest sense as safe economical passage from A to B via selected points, waypoints, then the communication system could be considered as belonging to the navigation category. If, however, communication systems are regarded as those systems capable of transmitting speech over radio or wire links and other all systems as navigation, we are also obeying a sensible convention. Introduction of data link will require some amendment to the definition of communication system since non-navigational data will be transmitted but not as a speech pattern. Navigation system may be subdivided into radio and non-radio, but only the radio system concerns us here. Another possible subdivision is position fixing on a map, height finding, landing aid and environmental monitoring. Maintenance. Carrying out functional tests when called in for the schedule or when the fault has been reported should be done in accordance with the procedure laid down in the aircraft maintenance manual. A word of warning should be given here since the procedures are not always what they should be. Often testing of certain aspects of system function are omitted and rarely there may be errors in the procedure. A thorough knowledge of the system is the best guard against making mistakes and omissions which if noticed should be amended through the proper channel. Modern equipment usually have sufficient built-in test equipment, byte, and monitoring circuits to carry out a comprehensive check of the system. With radio system, however, special portable test equipment must be used in addition to BITE in order to be in a position to certify the system as serviceable. Test set should be capable by testing radiation and simulating the appropriate signal to test all the function not covered by BITE. Installation of equipment should be in accordance with the manufacturer's instruction, which will cover the following: weight of units, center of gravity may be affected, current drawn, loading of supply should be carefully considered, and current of choice circuit breaker made. Cooling, more than adequate clearance should be left and forced air cooling employed if appropriate. Overheating is a major cause of failure. Mounting, anti-vibration mount can be necessary if non-metallic give rise to need of bonding strap. Compass, safe distance, radiation hazards, cables, length and type specified. Usually maximum length must be observed, but in some cases particular lengths are necessary. Types of cables must be provided a protection against interference and be able to handle current drawn or supplied. Current capabilities are reduced for cables in bunches. Antenna, approved position for particular types of antenna or particular types of aircraft are laid down by aviation authorities. Strengthening of the structure around the antenna in the form of double plate will probably be necessary. A ground plane is essential and must not be forgotten if antenna is to be mounted on a non-conducting surface. If antenna is movable, adequate clearance should be left. Any alignment requirements must be met. Interface, compatibility with other system or units must be ensured. Both impedance matching, including allowing the capacitive and inductive effect, and signal characteristics should be considered.